Hello, I'm Gary Harrison from LiDAR Tech UK. In this session, I'm going to walk you through the key operational precautions and best practices when using the FJ Dynamics Trion P2 and S2 LiDAR scanners. We'll cover core SLAM principles, preparation before scanning, challenging environments, and advanced workflows like breakpoint scanning and registration. If you understand why the scanner behaves the way it does, your data quality improves dramatically. One important operational difference between the older P1 and the newer P2 and S2 models is scanning posture. With the P1, operators would often need to tilt the scanner upwards at around 45 degrees. With the P2 and S2, this is no longer necessary. You can hold the scanner perpendicular to the horizontal plane, which is more natural and helps to reduce operator fatigue. This also improves consistency in indoor and corridor environments. Let's start with fundamentals. The P2 and S2 operate using SLAM, which stands for Simultaneous Localization and Mapping. SLAM works by identifying and tracking distinctive landmarks in the environment, such as corners, edges, and structural transitions. Here's the golden rule. Geometric complexity equals more stability. Simple shapes like corners and intersections provide the scanner with strong 3D reference points. Another key concept is loop closure. By walking loops, you allow the scanner to recognize a previously mapped area in order for it to correct accumulated drift. Remember, if your environment lacks features, your stability decreases. Long corridors are one of the most common SLAM challenges. The issue is uniform walls with repetitive geometry. There's nothing distinctive for the algorithm to lock onto. The solution is to add artificial features. You can do things like placing cardboard boxes or other distinctive objects at irregular intervals. This breaks symmetry and provides anchor points for the algorithm. Always remember, the environment must have angles, depth variation, and edges. Tunnels and narrow spaces present two main issues: reduced field of view and uniform geometry. You should therefore hold the scanner at a middle to low height. Make sure you capture ground texture and move slowly at 0.5 meters per second or less. Slow movement gives the algorithm time to identify subtle features. If possible, have colleagues stand on either side of the tunnel as static markers. You should also avoid turning around repeatedly, or rescanning the same section as this can introduce noise to the scan. Forestry introduces a different challenge. Moving leaves, especially in wind, are poor SLAM features. In addition, large open woodland can also cause drift. Path planning is therefore critical. Use an S-curve route or concentric circular paths to ensure good loop closure, and keep the scanner focused on effective features such as tree trunks and ground, not sky or canopy movement. Before single tree segmentation and processing, ensure that you manually delete outer noise areas like sky points. This improves classification accuracy significantly. High-rise buildings can introduce accumulated vertical error. It's better if you do not scan an entire building in one continuous run. Instead, scan floor by floor as individual scans. When you are scanning the stairwells, always walk in the center whilst pointing the scanner toward the stair centerline. The steps themselves create strong repeating features. Later, stitch floors together in the Trion model software using shared geometry or coordinates. The function continue scanning allows you to stop and continue a scan later, but this must be done carefully. You must return to the exact physical stopping point. And critically, the scanner's orientation must match the end orientation perfectly. This is because the SLAM algorithm needs consistent visual alignment to relock into the scanning map. If your pose is off, registration errors may occur. Registration connects two separate point clouds. Here, overlap is essential. You must also have a significant common area between the two scans. That overlapping area must contain distinctive features, not blank walls. And ideally, floors should connect at 2 or more points, such as 2 stairwells. This helps prevent tilt or inclination errors in the final model. Here are the key do nots today. Try to avoid large glass walls. Their reflections can corrupt data. Do not open or close doors during scanning. This causes double layers. Always prop open doors before starting the scanning process. Minimize moving objects in view. And keep your individual scans under 20 minutes to help manage drift. Preparation is everything. Remember to add features to corridors, slow down in tunnels, and plan curved routes in forests. Success lies in careful planning before you press to start the scan. Thanks for watching. I'm Gary Harrison from LiDAR Tech UK. If you'd like a live demo of the FJ Dynamics Trion P2 or S2 scanners, or guidance on advanced LAM workflows, please get in touch at lidartech.co.uk Remember, accurate data starts with good technique.